Hello and welcome to another video. Today we have an AM4 board, a B350 Pro-Vdh from MSI. This board came to me for the reason the owner changed the CPU in this. He wanted to upgrade his CPU, and after he upgraded, this board wouldn't post anymore. So there are two things that I would expect here. One thing is that he didn't have a compatible BIOS, that maybe this needs a 5000 series BIOS in order to work with an upgraded CPU. One more thing could be that he put in an unsupported CPU in here. There are some APUs that are not supported in any way with any BIOS on some AM4 boards. That could also be the case. And what is most likely, in my opinion, is that there's now some physical damage on this board. Then when he removed the cooler around the mounting points or around the CPU socket, that there's a component knocked off or maybe not making proper contact anymore. There could also be something related to the slot then, but I would expect most likely some small components being knocked off around here. So what I'm going to do now is I'm not going to do measurements in the first place. I'm going to look around for physical damage, and where I'm going to look is around the mounting points for the cooler, for the CPU cooler, and also for the mounting points around the actual screw holes for the main board. So all around the main board I'm going to look, maybe even if for the SSD, and very importantly also around the PCIe slot, because if this person took out the whole board to swap out the CPU, they also probably taken out their GPU, and something around the GPU could also be knocked off. So I'm going to go on the microscope um, and going to have a look if I find anything, and I will see you then. And now we are back, and as you can see, I found physical damage, and some quite rough one, to be honest. This goes quite similar to one of the things that I expected. Someone probably had a GPU in here that he wasn't able to remove this latch. So this is the latch that you have to disconnect in order to get the GPU out. And what I would expect is that someone used a screwdriver to punch this down or to push it down, and he got it down, but then slipped and tore right through these traces. And now we have the very nice option to look around and see which of these traces actually got damaged to the point that they are broken, and which of these have continuity. So I can already see quite some that look awful. So let's see together here now. These traces here at the very end, I think they survived because these are quite thick traces. So I wouldn't, these aren't the first suspect. Oh, well, it's pretty deep. I'm actually going over it with my tweezers right now, and I'm feeling a really, really deep scratch. But I think this one, for example, is still good, just like this one is. But the thing that I can definitely say, I think all of these here are dead. Like these in the middle here look awful. Hmm. I'm trying to scratch a little bit off to see if there's any copper left there, because I think these, for example, these are good, I think. These lower ones here. Another problem could be this wire down here. This could also cause a problem. And there's nothing down here that is damaged. So I can't see any component here missing. It seems like the furthest point that he has gotten with the screwdriver is around here, which doesn't matter because this is just all ground. And he didn't hit this one, I think. So this is still good. But yeah, we need to find out for these traces. I'm going to get some IPA ready. I want to clean this up and see if this is just masking that is left over there that he scratched, or if there's actually traces damaged. Let's see. I got the IPA ready. Let's go over a little bit. Okay. This, oh man. Uh, Yikes. Yeah, this made it a lot clearer. Oh boy. Hmm. Let's count how many traces we can see that are ripped. So I think these four might be good. This one in particular might be bad, but I think these are good. But we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. At least 13 traces to repair here. Oh, that's just great, man. This is going to be so much work. And isn't a mainboard that is worth too much money. So this is I will definitely fix this. But I'm not too sure if I'm going to do all of this in one sitting. So the place is kind of awkward here because the thing is you have this connector. I'm going to see if I can remove this to get myself a little bit more space to work here so I don't ruin it. And also a little bit lower, you have the NVMe connector for the M.2, which also could be a problem. Ah, so one thing I want to do together with you. Um, these traces you can clearly see they are dead, but I want to confirm with you if some of these traces at the top here are also dead. So what we're going to do, I'm going to get my Dremel and we're going to see together. One moment, please. So the Dremel is hooked up. You probably can hear it already. And now what we're going to do is we're going to Dremel some of the masking away right here. You want to hit behind and after the actual break to expose some marking like this. Let's do some here as well. I got to be honest, the more I'm dremeling, the more I think these traces might be ripped as well. So, and these were the ones where we definitely know that they are broken. So we got quite some mask dremeled away. Now we're going to take IPA again. And let's clean the spot up. So, next thing we're going to do is to take our multimeter, go into continuity mode. If I touch the leads, it should beep. It beeps, I hope you can hear that, because sometimes audio compression takes that away, but I'm going to tell you if they are beeping or not, and right now they are. So now let's see, I need to orientate the board a little bit differently so I can have better access, because as I said, the PCIe slot is quite in my way right now. Let's see now, we go the front, at the back, this is still connected. Let's try here. I think there's too much masking still on there, on that thick trace. Let's take some more of that off. Now we have masking off. Now let's take our leads again and see. Yeah, that is connected. This one is already also broken. Interesting. As you can hear, if I touch my probes, you can hear beep, but yeah, this trace is pretty, yeah, pretty sure it's broken. Let's see. You know what? I'm going to get other leads that are a little bit more pointier, and we will be right back. And now we're back with really pointy tips. It also beep. So this one is still good. This is good. This seems to be good, but yeah, it is good. Yep. This is good. And this is good. So these all traces look bad, but they are all fine. And yeah, this one you can already see this. These are dead. These are definitely dead. So I was able to show you that these four, they got damaged, but are still good. I might add some solder to these to the moment where they got damaged, but I'm probably just going to put some masking on there, and these are going to be fine. But these ones, you can definitely see how you can see the little ends of them, that they are ripped off and they need bridging. So all of these need to be done. I'm maybe going to film and commentate like how I do a single or two of those, and later then I'm going to do the rest off screen and going to get you back when all of them are done. But now I need to get some tools prepared, some jumper wire, and so on and so forth. Well then, I got set up a little bit. Let's see what we can do now. First things first is I would want, because the first pads are already exposed, the copper of them. First things first, what I want to do is to get some solder onto them. Now we get flux. We flux this position up. I'm taking the tiniest tip that I have for my soldering station. Let's see. The tip is linked in the description. It is the C245030. That's the tiny tip that I'm going to be using. We're going to turn on our soldering station. And now I just want to get this little place right there. Going to try. This is the problem now. There are so many things in my way. That looks good already. We have now got solder onto those pads. And now for the thing that I'm doing to get a jumper wire is I use solder braid. Let's see if I can show you. This is my standard as solder braid. And what I'm doing is I'm using this wire to solder onto there and use as a jumper wire. This is not enameled wire. Be careful with that. This is not allowed to touch anything else. So this is now, I don't know if you saw how much I struggled, but this is now how it looks. I'm not too sure if we got the gap actually bridged. So I'm going to remove some more of the mask right here, so that I will be able to probe here and right here as well. Get some masking removed. Now we're going to take the multimeter again, put it in continuity mode, and let's see if that bridged wire did what it needs to do. Going to go right there, right here, and that works. And the wire is solid, as you can see here. It's solid right there, solid right there. So this trace is now repaired. And yeah, this is basically the process I now need to do for all of these traces. This one trace took about 5 or 6 minutes. This is sadly this is one of the easier traces. So the other ones are going to be a lot harder because they're a lot closer to each other. And yeah, when they're closer to each other, you tend to knock off a different wire again, and you will need to do the whole thing again. So I don't know if I'm going to fast forward this or just going to skip how I did it. I'm going to let the video roll, and later in editing, I'm going to decide if I'm going to show you how I did it or not. And yeah, one thing I can say, be careful how much flux you use, because for me, for example, I just used too much flux, and the flux actually gave me a hard time actually seeing what I was doing. So always be careful with how much flux you want to apply to the point where you're working. An anti-glare light might be a good investment then, so you could actually see what is happening. But I have only the monoocular microscope that I use, and this is what we're going to work with now. And yeah, so see you in a bit. And now we are back. This took approximately an hour, about an hour. The beginning was quite rough for me, to be honest, getting back into this kind of micro sorting. But by the, I think, fifth or sixth wire, I got some pretty good speed with how fast I was doing this. At this point, with these two, I had to redo the upper one because I was doing the lower one and that got attached to the upper one. But we have all of these traces now. I checked all of them with the multimeter. They are all continuous. None of them are touching, even though it's hard to see. But these are not shorted, even though it looks like it. And yeah, there needs to be some solder mask. I need to put solder mask on this. But before I want to put solder mask onto this, I want to throw in a processor and want to see what it does, if we actually fix the problem. And we also need to find out if the first PCIe slot is working fine, because I've also removed the clip on the top here, because it was getting quite in my way and it took a lot of force, to be honest. I hope I didn't break anything in the process even further. But yeah, we are going to build this board now up, and I'm going to see you then when it's built up, and we're going to see if it's going to turn on now. And now we are back. As you can see, the board is fully built up. We have my postcard, we have a CPU with the CPU cooler, we have the GPU. There's no retaining clip on there yet. And as you maybe can see, there's a lot of exposed copper down there. That is where our damage was, our repaired damage. And in the bottom right, you can see our power supply. I have not attached it to power yet. I'm still missing the positive lead off of my lab bench power supply to connect to our 24-pin adapter. And we're going to do this together. In the top right corner, the blank screen that you see is our capture device for the post of the main board. And now I'm going to touch the probe to our adapter, and we're going to see the current. And that looks like about 10 milliamps. 10 milliamps. Yeah, right. We're going to attach our speaker quickly onto here, so we get a post beep. And also we're going to attach our button. Now we're hitting the button. Looks very good. We have post LEDs on the right here, which had CPU first and turned off, and now turning on again and off again. Amps look very good, about 6 to 7 amps. We have VGA, and VGA is off again. And now we should get boot. All LEDs off again, and now we have VGA again. And we have boot. As you can see, we are in the BIOS. Very nice. Yeah, what can I say? The board is fixed now. I need to go into Windows to check if the PCIe slot works completely, and that we get 16x into this slot, because some of these traces that went to there might be related to PCIe, and they might be related for some memory stuff. I don't think so, because they run down there and I would expect memory to go there. But what I'm going to do is I'm going to plug RAM into here, going to test the SATA ports that are on the side here. I'm going to test some USB and Ethernet and so on and so forth. But I think we're good. If there's any other problem coming up while testing, this video will continue. If there's nothing else, then this video will come to its end right now. Now I want to say to everyone, thank you very much for watching yet another fix, this time with physical damage caused by a screwdriver most likely, trying to open up the retention clip of a GPU. Hit the thumbs up if you liked the video, hit subscribe. There's always a new video every week of fixing ATX mainboards or things that are related to that. Hit the noti bell so you don't miss any of my content. Thank you very much for watching. See you again soon. Bye.